All right, this last section of chapter 10 is all about the parabola. Now, you are familiar with parabolas at this point, but you've only probably seen vertical parabolas, either going up or going down. What we are going to see in this section is not only vertical parabolas, but also horizontal parabolas. So going to the right and going to the left. We're also going to see some new aspects of the parabola that you have not seen before. The definition of a parabola is the set of points that are the same distance from a point and a line. And that point is the focus, and the line is what's called the directrix. So all the points along this curve, every single set of points along this parabola is the same distance to the focus as it is to the directrix. So the different parts of the parabola, some parts that you are probably already familiar with is the vertex and the axis of symmetry. So when we looked at parabolas earlier this semester, we also looked at x-intercepts. We talked about domain and range, x and y-intercepts, all of that. The pieces we're going to be looking at from a conic sections standpoint is the vertex, the focus, the directrix here, that is this line beneath the parabola, the axis of symmetry, which is what splits it in half. It's symmetric across each side of that. And then this line that goes through the focus is called the latus rectum. It is a Latin word. I'm not sure why that's the term we use, but I always abbreviate it as LR. So you will be having equations written in this form where you have y squared equals 4px or x squared equals 4py. And this distance of 4p is what gives you all the information for all of these pieces. Your focus is going to be a distance of p from your vertex, and your directrix is a distance of p from your vertex. And then the length of the LR, the whole thing, is 4p. So 2p on one side and 2p on the other side. So these are the four different shapes you'll see for parabolas. A horizontal one going to the right, going to the left, going up, and going down. On the next page, you can see the general equations where the center might not be at the origin. So x minus h, again, h is always with x, h is always with x, k is always with y, k with y. And if your y is squared, then that's a horizontal parabola. If your x is squared, then that's a vertical parabola. Over here, this factor is not squared, and you have this 4p value in front of the other side. Now, this 4p value, again, that p tells us all the information we need to know for our graph. So if that is a positive value, then the horizontal parabola is curving to the right. If this p value here is negative, it's curving to the left. If in the vertical parabola that p value is positive, it's going up. If in a vertical parabola that is a negative value, then your curve is going down. So when we find our vertex, we have that point. And then once we use that 4p value and we find p is equal to 5 or something, our focus is inside the curve, 5 units, and then our directrix is 5 units behind the curve. And then out 2p in each direction gives us those 2 points, and then we can draw our curve. So let's get into doing some examples. This first example here, we have y squared is equal to 24x. And since the y is what's squared, I already know this is going to be a horizontal parabola. And since my p-value is positive, I know that this is going to be curving in a positive direction. So I'm already expecting this shape of graph. Now, there's no h or k on my x and y, so I already know my vertex is at 0, 0. And so I can go ahead and plot that point. And I know that my curve is going to curve this way. So 24 is equal to 4p. P then, dividing by 4, would be 6. And so my focus is going to be 6 units inside my curve. My directrix will be 6 units behind my curve. And again, I know already that it's curving this way. If it was curving this way, my focus would be over here and my directrix would be over here. So sometimes I'll do this in pencil just real lightly just to help frame what I'm expecting to see. I'll do real lightly in pencil, a curve going that direction, just so I remember, oops, this should not be curving this direction. It should be curving the other direction. Just so I remember what like I'm kind of expecting to see with my graph. So again, my p-value is 6, and I think it's going to be best if I count by twos here. So 2, and then I'm going to count by twos on the y-axis as well. So if you're ever not counting by 1, you want to label what you're counting by. So my focus is 6 units this direction. So 2, 4, 6, and that is my focus. And then my directrix will be 2, 4, 6 units this way, and that is a vertical line behind my parabola. And so the equation of that line is x equals -6. My focus is at 6, 0. And then my LR goes through the focus, and the whole distance is 4p. So the whole distance is 24, but I'm going 12 in each direction. So half of it in one direction, half of it in the other direction. So 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. And that gives me the points I need to draw my curve. And I can erase this pencil that I did initially. Okay, so there's our graph. Those endpoints then were at 3, 12 and 3, -12. Or not 3. Looks like 3, but we counted by twos, so that's actually 6. All right, so there is our first example. Let's do another. So here we have x squared is equal to -6y. I have x squared, so that means this is going to be a vertical parabola. And because my p-value is negative, I know that my curve is going down. So I already know to expect that. I don't have an h or a k, so I already know my vertex is at 0, 0. So I can go ahead and plot that point. And again, real lightly in pencil, I'm expecting to see something like this. So -6 is equal to my 4p value. Dividing by 4, I get -3/2 for p. So I don't really need to worry about it being negative. We're really talking about a distance here. So 3/2 is 1.5. So my focus is going to be inside the curve. My curve is going down, so my focus is going to be 1.5 this direction, or 3/2. And so that would be at 0, -3/2. And then my directrix will be 1.5 this way, and it'll be that horizontal line behind my curve. And that's y equals 3/2. For your directrix, it should always be written as an equation. It should not be the number 3/2. It should be y equals 3/2, that horizontal line. Or for the one that we just did, I wrote x equals -6. That was a vertical line behind the curve through -6. So it should always be written as an equation, not just a number. And then because my p-value is -3/2, or my whole 4p value is -6, through that focus, I need to go half of that in each direction. So I'm going to go 3 this direction and 3 this direction. So that gives me the two endpoints of my LR. That would be at 3 and -3/2, and -3 and -3/2. And so I can draw my curve, and then I'll go ahead and erase what I did in pencil first. So there is the curve of our parabola. All right, the next example, we have the focus at -1/2, 0, and the directrix at 1/2. So they didn't give me any other information other than those two pieces. The directrix being at 1/2, I'm going to label my points here. This is 1 and this is 1. So if those are each 1, then this would be 1/2 and this would be 1/2, 1/2, and 1/2. So x equals 1/2 is my directrix, and my focus is at negative 1/2, 0. Well, my vertex is going to be halfway between that point and that line. So my vertex is at the origin. And that means the distance from the vertex to the directrix, or the distance from the vertex to the focus, that p-value is 1/2. Okay. Now I can see my center is at the origin, and if I have a vertical directrix, my parabola is going like this. So that's a horizontal parabola, and it's curving to the left, so I know that I have a negative p-value. And I know my center is at the origin. So y minus k squared equals 4p times x minus h. My h and my k are 0 because this is at the origin. My p-value is 1/2, and it's actually negative 1/2 because it's curving in a negative direction. So I actually already know all the pieces I need in order to write my equation. Y minus 0 is just going to be y squared. 4 times negative 1/2 is going to be negative 2, and then x minus 0 is just x. So this is the equation of my parabola. Two more examples here. Number 4, we have the equation of our parabola. And because I have y squared, I already know this is going to be a horizontal parabola. And then with my p-value being negative, I know it's curving in a negative direction. So that's what I'm expecting for my graph. My vertex, my h is with x, so negative 3. My k is with y, 1. And my p-value, I can solve for dividing by 4. Negative 4 is equal to p. And my center at negative 3, 1. I'll go ahead and plot that point there. And p is negative 4. Again, we're just worrying about the distance. I don't have to worry too much about that negative because I already know that my curve is going in this direction. So my focus is going to be inside that curve, a distance of 4. 1, 2, 3, 4. There's my focus. My directrix is going to be on the other side, 4. 1, 2, 3, 4. It'll be the vertical line through there. So my focus is at 1, 2, 3, 4, 5, 6, 7, 1. So negative 7, 1. And my directrix then is the line x equals 1, this vertical line, x equals 1. And my axis of symmetry, we haven't done that in any of these examples yet, but my axis of symmetry is going to be this line that cuts my parabola in half here. So that equation of that line is y equals 1. So that's my axis of symmetry. And then the end points of my LR, remember those go through the focus, and the whole distance is going to be 4p, so that's 16, but we'll be going half in each direction. So 8 one way and 8 the other way. So going up 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And we are off our graph. There we go. And there's our curve. Go ahead and erase my pencil sketch here. And there's the graph of our parabola. So those endpoints of the LR then are at negative 7 and 1, 2, 3, 4, 5, 6, 7. So negative 7, and then negative 7 and 9. Okay, last example. And here we have, again, something where we're going to end up needing to complete the square, but we only have to do completing the square once with parabolas because there's only one variable that's squared. So even though it didn't ask us to find these things, it would be good practice for us to do that. So I'm going to have us find all of those pieces. I want to get this in standard form. So I have x squared. And so minus 8x plus something to complete that square. And then I'm going to get the other pieces onto the other side of my equation. So equals, and I'm going to add 28y, so positive 28y on the other side, and plus 208. And then whatever we add to one side, we have to add to the other side as well. Now remember what's going in this box is that b divided by 2. So there's no coefficient here that I have to worry about. There's not like with ellipses and hyperbolas where we had to pull out that a value. In this case, it's already there. So, or it's already 1. So what I'm putting in this box is my b value divided by 2 squared, and that's what's going in here as well. And that, in this case, -8 divided by 2 is -4. -4 squared is 16. So I'm adding 16 to both sides. So writing that as a perfect square now, I have x minus 4. Remember that what is going in that set of parentheses here is your b value divided by 2. And then that's squared. And then equal to, and we have 28 y, and 208 plus 16 is 224. Well, I want to pull out that common factor of 28, and when I pull out that 28, I have y plus 8 in parentheses and equal to x minus 4 squared. So now it is in standard form for a parabola. And because the x is squared, I know this is going to be a vertical parabola. And because my p-value is positive, I know it's going up. So it's vertical and it's going up. So from my equation now, I can see what my vertex is going to be. H is always with x, so that's 4. And then k is with y, so 4, -8. So 4, negative 1, 2, 3, 4, 5, 6, 7, 8. And you know what? I think we're going to need to count by twos here. These numbers are just too big. So we're actually going to count by twos on the x and the y axis. So plotting my vertex here, 2, -2, 4, 6, 8 is right here. And again, I'm going to do this in pencil again. I know my parabola is going up. So I'm expecting to see something like that. And 28 is my 4p. So dividing by 4, p is equal to 7. So my axis of symmetry, I already know. Once I know my vertex here, it's this line cutting my parabola in half. So that would be at x equals 4. And then my focus is going to be 7 units inside that curve. So if this is at -8, going up 7 is almost at the x-axis. That's at 4, -1. And my directrix is going to be 8 units below my curve. So 2, 4, 6, 8. And it's that horizontal line there. And that is y equals -15. And then my LR is going to be through the points of my focus there, and that'll finish off what we need for this problem. So remember the whole distance for P is 28, so I'm going 14 in each direction. So 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14. And we have just enough space for this one. And there is our curve going up. I can erase my pencil sketch here. And the endpoints of our LR then, this was 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18. And -1. And then 2, 4, 6, 8, 10. So -10, -1. And that brings us to the end of section 3.